to introduce Johannes Schuetzner. Did I say your name right, Johannes?
Yeah, that was perfect.
Okay, so Johannes works at Mercedes Benz Research and Development, and you actually work on the Mercedes Benz operating system. Is that right?
Yeah, that's right. That's kind of the
Okay.
big topic we're working on. Yeah.
Got it. Well, maybe you also work on other things that you can't talk about. But the thing that you're here today to talk about and to share with us are your first experiences with Azure Database for Postgres, specifically the new flexible server deployment option. So I'm really interested to hear what you have to say and what your story is, and I'm sure everybody else is as well. So you can take it from here. Thank you.
Yeah, thank you, Claire. I'm glad to be here. It is my honor to be a part of this event. As I said, I'm part of Mercedes Benz R&D in Sindelfingen, Germany, and we develop software running in the cloud. So it's really a group of people developing software for the cloud, and we rely on Postgres as database server. So we were quite interested when we learned about the new Azure Database Postgres Flexible Server that was introduced last year. So there are a number of capabilities and features available that appeal to us. So my goal for this session today is to share our experiences and lessons learned. So it's kind of based on different discussions we had with other teams internally and also externally. And it should hopefully then make your journey to flexible server a little easier if you plan to go there. A little bit on my background. I've been in software development for a number of years related to database processing. I was working in the enterprise application space and also have worked closely with banks in like South Africa and Australia for some reason. Okay, so what are we gonna cover today? First, I would like to set the context of what we are doing. So it's MBOS, Mercedes Benz operating system. So I'd like to talk about this briefly and then show what we are developing specifically. After that, I will introduce the new Postgres flexible server offering, show its capabilities, and also highlight some of the differences to the kind of traditional Postgres single server in Azure. And then the main part will be sharing our experiences and lessons learned. And I intend to follow more or less kind of a typical kind of workflow. Like first we like to provision the flexible server, then take care of network security, some operational aspects, and then finally talk about the new burstable compute here and zone redundant HA. Okay, so Mercedes Benz operating system. So what's that? And basically, it's a standardized software platform that's the foundation for the next generation of Mercedes Benz vehicles. So it's really the relationship between the cloud infrastructure software in the car, Internet of Things devices, everything that's kind of the base software that is then needed to make these future vehicles run and operate. There are 4 vehicle domains in MBOS: automated driving, infotainment, driving and charging, audio and comfort. And it is developed both in-house and with partners. So there are multiple locations, like in Sindelfingen, where we are located, but there are also other Mercedes-Benz locations around the world. The building that is highlighted in the middle of the slide is the new electric software hub, and just by chance, it was officially opened last week on Friday. So that's kind of one of the center pillars of these activities. And if you think that's kind of an interesting topic, and this is really something for you, we're currently hiring. So if you're interested, then you may have a look at our website and check the job postings. So in this context of MBOS, I mean, there are different use cases. Many focus just on single vehicles, but then there are also other use cases where a set of vehicles needs to be treated. So for example, you need to roll out software to this set of vehicles, or you would like to enable feature toggles for a specific set of vehicles. And that's why fleet management is an important topic there. and it also allows then other applications to really use predefined fleets so that these different tasks all operate on the same sets of vehicles. So that's why kind of fleet management is one of the underlying components of the overall infrastructure. And we developed this solution. It is based on like multiple microservices. It's a cloud native approach. It requires to encrypt the data with kind of Mercedes Benz owned keys, or for data security, data privacy reasons. Typically, each microservice has a dedicated database to store its data. But we don't only have like single instances per microservice, but also like we have typical like dev, non-prod, prod environments. Then we have multiple regions across the globe for the different markets and different customer bases. So that's why really we have a number of databases, and so to keep these databases operational and manageable and to be able to exploit them as good as possible is important to us. Since Mercedes Benz is committed to open source, using Postgres for the database server is kind of a natural fit. And so we've used the Azure Postgres Single Server for a number of years, and this has worked fine. There were some observations that we made over time. So, I mean, we were still in Postgres version 10, so it's kind of a little outdated in the meantime. Then we encountered from time to time some issues with the SMB file handles to access the data on disk. So there were some issues there. And then, of course, the workload varies, and also depending on the state and on prod, I mean, the workload is typically way bigger than on the dev environment, where some developers develop software and run some tests, but nothing much going on otherwise. And so it would be good if the costs are then only kind of incurred when there's really big workload. I mean, that makes sense. But on the other hand, if there's no workload, like in a dev environment during the night or very little, then it would be good if we can reduce the costs. A good thing about Postgres Single Server is that as a managed service, it takes care of applying maintenance under the cover. If there's a new like operating system patch that's required, or some new Postgres minor version or patch, then this is all applied automatically. But it's not possible to decide when this will gonna happen. There's some information like from Azure and Microsoft in advance, like 3 days, I think, but then it's a 15-hour window, and so it may be at a convenient time or at an inconvenient time. Yeah. And then the last bullet here is kind of, as the name suggests, is a single server. So in case of an error, it needs to be restarted, and so there's no failover solution because it's really a single server. And I think having a failover solution provides some enhancements. Okay, and then that's kind of based on our own architecture. So we set it up such that every database resides in a dedicated Postgres server. I mean, this works fine. This kind of full separation, but there's some overhead probably, and so we have a potential here for server consolidation. So that's why we looked at how can we improve things based on Postgres flexible server, and it was introduced end of last year. So the Postgres flexible server in November of 2021. As you can see on the right-hand side, it's one of the options available for Postgres on Azure. That's also something that Magnus showed in his keynote earlier today. So I mean, there's single server still available, then there's flexible server, then the Citus offerings, but it's one new option that is available. And one big difference is already it's running on Linux. So Postgres single server is based on Windows, and flexible server runs on Linux, like natively. I think that's an advantage, and it is more up to date regarding major Postgres versions. So it supports currently versions 11, 12, 13, 14 not yet, but probably this will also be available soon. And with Postgres single server, it was only version 10 and 11 that's supported. So I mean that shows really Azure is probably more committed to keeping this up to date and to remain current. And I think that's good, because with every new Postgres version, there are enhancements and new capabilities. So it's good to be able to take advantage of them. So there are a number of enhancements there. I picked 6 of them here. Sorry, just 5. Just 5. And would like to highlight them. So there are some cost optimization options available that are improved compared to a single server. There's a new burstable pricing tier. So I will talk about this in more detail later. Also, it's possible just to stop the server, like for dev systems where there's no workload at all during the night. That's a benefit. Then it is able to scale across pricing tiers. So again, looking at dev environments, maybe you will start small, you will just, I don't know, play around with, and then you can use like a simple basic pricing tier, and later you would like to scale. And this is not possible with single server. You have to unload and reload the data, and with flexible server, you can just scale across these tiers. A really big enhancement, in my point of view, is the zone redundant high availability with synchronous standby. We have 2 Postgres server, and they are transactionally consistent. And in case one of them goes down, then it is possible to fail over without losing data. Then the PG bouncer connection pooler is available. There's an option. You don't have to use it, but you can use it directly on the server side. And then finally, you can schedule your maintenance windows. I mean, the maintenance windows that Azure uses to apply for your Postgres instances. Okay, so let's have a look at our hands-on experiences. I mean, they're really kind of, I don't know, hands-on, some basic observations, but I think it can help just being aware of them, so that kind of, I don't know, you know what to expect and how to deal with these changes. And I think these changes, some of them are also documented in the documentation, of course, but for me at least, it was such that, I mean, I've read about them, but then when I saw it, it was a more kind of, I don't know, more immersive experience. So in our case, we use Terraform for the deployments of the Azure infrastructure. And so we had to update our Azure provider so to have a version that supports Postgres flexible server. So we are on 2.91.0 now, so that works fine. And one limitation so far is that customer managed encryption keys are not supported yet. So bring your own key. So that's not yet available, but I heard that will be coming, so it's a matter of time. But that meant for us, so that for now we provision the flexible server only to our dev environments, where we have really just generated data, test data, no real data, so there it doesn't matter. And so we plan then to go to Flex server on other stages later. The goal of our setup was then to be able to provision these different types of flexible server in a single pipeline, so that we can just specify, okay, for example, in dev, we would like to have burstable Postgres flexible server for non-prod, currently single server, in the future flexible server with zone redundant HA. So we need to be able to, just by, I don't know, making a check mark somewhere, changing a flag, saying, okay, I would like to have burstable here and flexible server zone redundant HA in the other environment, for example. Okay. So what we did was then to define a resource in Terraform here for the new Postgres flexible server, and then for this queue name attribute, we have a variable where we can say, okay, that's burstable pricing tier or general purpose pricing tier or something else. And then there's a new parameter for the high availability configuration. So I mean, this looks straightforward, but the downside is that it doesn't work, because the high availability attribute is only available for general purpose or memory optimized pricing tier, but not for burstable tier. So it's not supported there. And so what we did was to introduce further variables and the Terraform dynamic block in the resource definition. So as you can see, we have like for dev, we have a variable high availability equals null. We don't need it there. The SKU is B standard, so B stands for burstable. And then for non-prod, we say, okay, SKU is GP, general purpose, and for the high availability config, we use a variable. And I show you this variable on the upper left, on the upper right of the slide. So it just has two values, the node, so zone redundant, and the standby availability zone. And then on the left-hand side, you see this dynamic block at the bottom, dynamic high availability. And what it does is that it reads this variable during kind of deployment. And if it's kind of empty, then the whole block goes away. And if there are some values in this block, in this variable, then these values from the variable are then inserted into the block, and then the parameters are available. So that way, we are able to have a single resource definition and still can distinguish these different setups. Also, there's one attribute called zone, and that's also quite useful because there you can specify the Azure availability zone. And so you have control in which availability zone your flexible server will be provisioned. And if you have this collocated then to your application, like to your Kubernetes cluster being in the same availability zone, then you have a better latency because then application and database are in the same zone. Network security for the single server, there was an option to have multiple VNets that are associated for a flexible for Postgres Single Server. And that means all components within these VNets were allowed to access the database. But Flex Server is more strict and also maybe more clear. There are only two options: private access and public access. And with private access, there's no public endpoint. So that means, like from Azure CI/CD pipelines, you cannot access the server directly. When you can have self-hosted agents, for example, then it works. But if you would like to have public DNS name and firewall support, then you would have to use the public access, which is what we did. And we automatically specify firewall rules as part of our deployments, and we use the IP ranges from the Kubernetes egress, so they are well defined, and so we can use these ranges and then insert them in firewall rules, and so that way we have then a proper configuration for all our environments. Okay, so at that point in time, the flexible server is available, up and running. Then typically the next step would be to create databases. So this is what we did. Here you see our Azure CLI command that we used for single server. When we specify Azure AZ Postgres DB create, then we specify a name, character set, collation for the order sequence. I mean, that's just standard. But then I was a little surprised because just converting this statement or command to the AZ Postgres flexible server didn't work. So we specified the same name, character set, collation, but what we got was an internal server error saying, okay, unexpected error occurred. Okay, and so I was a little unsure what was wrong with that. But then it turned out it's actually good because, I mean, remember, Postgres Single Server runs on Windows, and so we used the Windows-specific collation ID. So 1252, that's a Windows-specific code page. And actually with Flexible Server, we are now on Linux, and basically we only want to have UTF-8 data. And so with Flex Server, we are able to specify also UTF-8 for the collation ID, and so that's then a proper setup. So that's good. With the Flex Server, you don't have the Postgres server logs in the Azure portal. I mean, for single server that was available. With Flexible Server, there are multiple options, like you can have the Azure logs being propagated to an event hub, to a storage account in Azure, or to to the Azure Log Analytics, and this is what we enabled. And I think that's really powerful because then you can analyze your Postgres logs using the Custo language in Azure Log Analytics. So I think that's good. And then little comment regarding the CLI commands. Here in that example, it's Azure CLI commands, but for PowerShell and other languages, it's similar. So the commands are kind of different. It's not rocket science. It's not that they are completely separate and new. It's just that they are somewhat different, and that means that if you migrate to Postgres Flex Server, you would need to adapt your scripts to make sure that they are still running properly. Yeah, that's all just to be aware of. So some of the command options have different names. So more or less it's the same, very similar, but there are a few differences. Yeah, and also regarding monitoring, if you have like certain metrics that you use for monitoring dashboards or for your analysis in Azure, then there are different metrics. So in that case here, it's an example for Datadog where it's a different metric name. It's just, I think, important not to forget about them so that you still get proper metric values. Earlier, I mentioned kind of the cost savings that are possible with the Postgres Flex server. In our case, I mean, we did two things. We consolidated. I mean, we now have kind of a single Postgres Flex server per environment, and then we have the different databases within the single Flex server. So I mean, they're still properly separated because they are different databases, but it's a single Flex server, and we take advantage of the new burstable tier, and that's why for the dev stages we got a reduction of 86% for the Azure Postgres costs, which is really great, really great savings there, because I think there it's a really an excellent fit. So the workload is small usually, and we can consolidate perfectly, and we can take advantage of the burstable tier. So how does the burstable tier work? It is using these burstable VMs, and basically, if you have like if you have a pricing tier with one core, for example, then you are entitled to use 20% of that capacity at all times, and the maximum goes up to 100% per core, like 100% of one core for the first case. And the good thing is then if you have longer periods where you have no or little workload, then you get credits for the CPU consumption that you didn't use. And so, for example, if during the night for 5 hours there's almost no workload, then per hour you get like 12 credits there for the first size that is shown here. And then during the day, when the workload is bigger, then you can consume these credits. So I think for these environments, that's really a good enhancement that helps reducing the Azure costs. Let's get to the last topic that I've prepared for this session today, which is a closer look at the zone redundant high availability. And as you can see here, it is based on the availability zones. So you need to have 2 Azure availability zones, like 1 and 2 in that example. And your application connects to them as if it were a single Postgres instance. So there's a single domain name, and the application, like in the middle in this example, it always connects to this one logical instance. But internally, it's kind of primary server on the left and standby server on the right. So the server, so the application, always connects to the primary server, and all the data changes are then replicated synchronously to the standby. So that way, the servers remain transactionally consistent. So that means no transaction gets lost if it has been committed, and even if there's a downtime. It enables the failover, so that's what I like. So the application just needs to reconnect and then ends up with a new server if needed. And let's distinguish two cases, planned failover and unplanned failover. So for the planned failover case, like typically Azure would schedule an update of some internal software like the Linux operating system, or would perform a minor version upgrade of Postgres, like going from 13.3 to 13.4, something like that. So I mean, this is planned. You can enable this via like Terraform, via scripting, or here also in the Azure portal. And I show this here because maybe it's better better to understand it or to show it. If you enable this here, you say, okay, enable high availability, then you see the high availability status. And so initially, that's not kind of healthy. It's kind of catching up mode, because initially all the data changes need to be replicated from primary to standby, so they have the same data. And then once they have the same data and the log replication has been enabled, then it's healthy. You have the primary server name, and that's always the same, doesn't change. And currently, the primary is in availability zone 1 and the standby in zone 2. Okay, you can also then control your maintenance window here. This is also what you can do here in these Azure portal sites. How would it then work? So if your plan failover is started, the replication from primary to standby is suspended. Then as a first step on the standby server, the update can be applied, because then nobody is accessing the standby server anymore. Then all the changes that have been done on the primary server on the left-hand side, they are replicated to the standby. Then the connections from the service to the primary are drained on the left-hand side, so they're not allowed anymore. And then all the application needs to do is to reconnect, and then it automatically ends up with the new primary server on the right-hand side in the zone 2. So really from the application point of view, it's just doing a reconnect, and then all of a sudden it ends up on the second server here, former standby. Now it has been promoted to new primary. And then on the left-hand side, that's kind of then the new standby, and there's no workload. So that's why the maintenance can be applied there as well. And so really the impact is that kind of small to the application. Only here for the kind of this reconnection, there's a small kind of downtime. The other case is the unplanned failover, and this is what you would like to avoid. But I mean, you never know. Some underlying hardware component can fail. Postgres server itself can fail. In theory, I mean, anything can fail. And so the official statement from Azure is then the expected RTO is less than 120 seconds. So, but this depends largely on the actual workload. But what is really good about this approach is then in Azure portal, you can test this. So you can go to this panel again that I showed earlier and say, okay, now I would like to force the failover, so for testing purposes. And then this is failing over. You see the high availability status is now failing over. And at the bottom, you see the primary availability zone is now 2. So that means that really the switch is happening or has happened. So this is for the visualization of what I just explained. Initially, the data is replicated, then the primary fails, and the application reconnects and ends up on the secondary side. Okay, for our case, what have we seen for typical like downtimes or error rates? And this was in the range of 40 seconds. So as I mentioned, this depends largely on the actual workload, size of the workload, all these aspects. For us, it was like 40 seconds where we measured errors, which I think is good. It's good, but also don't get confused about maybe the messages in the operation log in Azure about the server, because you can see messages going way longer, but then this is more like background processing that can occur also after the failover. But then during these later phases, the application has already reconnected to the standby and is able to continue processing. Okay, so I think overall, the flexible server is a great offering. It's really a big step in the right direction. We like it, and I think we intend to roll it out further to more stages, also to other applications. What is currently needed is support for bring your own key, so that we can encrypt the data with our own key, and then also would have to have it in China. Yeah, with that, thanks a lot. I'm happy to answer questions also later in Discord. But if there are questions now, we can also discuss them.
Hey, thank you so much. I really appreciate your talk. And I know that the entire team in engineering and product that's been working on Flexible Server is going to be excited to watch it as well. Half of them are asleep right now, but the good news is all these talks are being recorded and they'll be published on YouTube and docs.microsoft.com. So people will be able to access them later. I do have one question. I think we have time for just one question, and that is whether you have any observations about the performance of Flexible Server as compared to Single Server on the Azure Managed Service.
Yeah, we have some initial observations, but not completely kind of reproducible, because the issue currently is from our side. I mean, on the flexible server side, we can control the availability zone where it is running. But on the application side, we are not there yet. It's kind of random. So another team is working on that, so we can also control the availability zone of the Kubernetes cluster. And then once we have that, then I think we can have proper comparison, because currently it's like impacted by this mismatch potentially. But I mean, from what we've seen, it looks kind of promising, but I think it's not kind of a good foundation yet to claim final numbers.
Yeah, so you've got good engineering training. You obviously have to measure it and know definitively before you can answer this question. So I understand. Thank you again for coming and joining us at Citus Con, for preparing this talk and sharing it with everybody. And yeah, we'll be following up with you and making sure that you've got all the links, and join us over on Discord. Thank you.